I will explain about the shapes of atomic orbitals. So shapes of atomic orbitals are very much important. It is in very beginning. Just you have to know the basics. So there are the dependence of the shapes of orbitals on different wave functions. Wave functions, I have said, wave functions, that is psi. I have said yesterday, so it is wave function. Similarly, this theta, then this phi, then radius. So they are the variables. They are the variables due to which any distance is measured. This the probability. This is length variable. Radius. This radius is length or distance variable, and theta and phi, they are the angle variable. These are the variables. These are angle variables, and this is length variable. So these are the parameters. Just you have to keep in mind. Now, how we come to know about the shape of an orbital? Just I have said yesterday that this psi, it is the wave function. Now, if we see the orbital, so for the s orbital, this on this axis there is the r. R is the radial wave function, and on this axis there is the radius. Here, zero center. So if we plot a graph, so this type of graph is obtained, and that there is always a possibility of finding of electron, but this psi has not any function. So this is for the 1s orbital. For the 2s, on this axis again there is r, and here 0, and on this axis here at this point, that the intersection, this curve intersects at the point, and here there is no electron density, 0, and so there is node, and here if you take it is plus, and so it will be in the minus. So just for the sake of convenience, plus and minus, they are introduced to differentiate the terms. Now, as I have said yesterday, this radial wave function or psi has not any significance. So significant lies in the probability. Probability means finding of electrons. So again, we draw a graph. This is for 1s, this is for 2s. So here the radial probability function or radial probability graph r square for 1s is similar to this. 1s is similar to this, and so it is never 0. It is never 0 means on both the axes there is always a probability of finding of the electron density. Now in coming to 2s, here see initially this line never touches to the this axis, but after some time it becomes 0, and this is called as node. This is called as node. Again, you may take plus, you may take minus, but it is not minus, it is 0. Again it increases, decreases, and it runs parallel like this. So on this basis, we can conclude, we can draw 1s and 2s orbitals like this. 1s and 2 orbitals like this. This is the 1s, just spherical symmetrical, electrons are throughout the available, and here in the center, just you have to see the center, there is the probability of the electron. So this is the pictorial representation. Here the electron density, this is the nucleus. So around the nucleus electron density is maximum, and as move away electron density decreases, but it never becomes 0. Electron density decreases as go away from the nucleus, but here electron density never becomes equal to 0. Now when we draw the 2s, see how 2s is like this. Now see, this is the again nucleus. Around nucleus there is a electron density, and this empty space, this is called as node. This is called as node. Node is the area where there is no electron. And again, the value of electrons or electron density here increases, and it never becomes equal to 0, and thus this is about the 1s and 2s orbitals. Now the p and f orbitals, they are very much complicated, but you know the p orbitals they are like this. P has 3, so this is the representation of, this is px, py, and this is about the p orbital.